So, okay, good morning. So we will continue with the slide that we stopped yesterday. So currently we are studying on the chapter 1, the introduction to communication system. So yesterday we have seen what is communication system and what you can uh, anticipate when you see or hear about the communication system. What are the elements in between? Because since it's a system, it is not only having one component, it must have various components working together. Okay, so we will continue from the place we stopped yesterday. So currently we are studying about the block diagram of communication system. So this is a simple communication system, so moving from transmitter until receiver. So there's a error here, a receiver. Okay, so when you want to communicate something, so you need to, let's say, like now I'm giving a lecture, so I'm speaking. So from my vocal cord I'm speaking, so that is the information source. So whatever things that I try to convey to you, okay, about the block diagram, so that is the information source. So the information source is entering the microphone in my laptop. Okay, so the microphone is the input transducer. So it is amplified, it is modulated. So I will tell you what is a modulation. Okay, we will study this in chapter 2 and chapter 3 also. So once it's modulated, it will be sent to the antenna. So antenna will transfer to the receiving antenna via a channel. Okay, so the channel will have additional noises that we need to filter it out. Okay, so then once it reaches the receiving antenna, it will be demodulated. So there can be a detection or other elements as well. Then it will be amplified and sent to the speaker so that you can hear. Okay, so you can hear the information source. Okay, so this is a block diagram for a simple communication system, a digital communication system. So it can be anything. So it can be a lecture, it can be a song. So whatever things that you want to communicate, so you just change the information source. Okay, so we will see quickly. So what are the elements? So we have seen there are a lot of elements involved. So we will see one by one. Okay, so yesterday actually I already covered this, but I want to repeat so that we those who didn't come to yesterday so can get the information. Okay, so first element is the information. So it must be the message or the information or the content that you want to deliver to other people. So you want to get it across. So you must have information. So without any information, the communication is not valid. Okay, so because you need to tell something, you cannot simply be silent and expect to them to understand. So you need to communicate something. Okay, usually it will be verbal. Okay, so it's an entity that is to be transmitted. So it can be in a form of audio, it can be a video. So one can be a sensor inputs like temperatures, pressures, or it can be a picture. Okay, so pressure, it can be a physical pressure or even from your touch screen. So touch screen is operated by the pressure that you apply on the touch screen. So it can be communicated as well. Okay, so once you have the information of the message, so you are converting it into a signal, which with time it will be carrying the information. So yeah, signal is like packaging, packaging of your information. So yesterday I gave the example. So if you want to send something from Perlis to Kuala Lumpur, so let's say you want to send a mango, Arum Manis mango. So you want to send, you cannot just go to the post office and just give them the mango. So ask them to send. So you need to package it. You need to put in a box. So you need to wrap it. Then you hand over to them. So this information is like the Arum Manis mango, and the signal is like the packaging. Okay, so you put the information in the signal and you are transmitting. Okay, the information is converted into electrical form for transmission. Okay, so there's elements that will convert, okay, analog to digital converter or digital to analog converter. So if we will use all these elements to convert whatever input that you want to give into a electrical form, then once it converted to electrical form, we can use a wire or wireless to transmit. Okay, so that's the second element. The third element is the transducer. So transducer is like a sensor. Okay, so it's a device or an arrangement that converts one form of energy to another. Okay, so electrical converts physical variables, okay, such as pressure, force, temperature. Yeah, so all these inputs are converted into electrical signal variations. Okay, so for example, the microphone I'm using now, so I'm converting my audio signals from my vocal cords. I'm talking to you, so it will be converted to electrical signal so that you can hear from your place. Okay, so it will be transmitted. Okay, and then we also can have like a sensors like photo detectors, so which converts light signal into electrical signal. So actually there are various kind of transducers and sensors out there. Okay, so everything can be classified under this category. Okay, so the fourth thing is the amplifier. The function of amplifier is to increase the amplitude. Okay, so you want to amplify something. Okay, so let's say your voice is at 2 volt of amplitude. So using the amplifier, you can increase it to 200 volt. Okay, so that's the function of amplifier. So amplifier will have certain values. Okay, so the gain that you want to convert, okay, you want to convert to 5 times or 10 times or 100 times or 200 times. So depends on the sizing. Okay, so it will help to increase the amplitude or the strength of the transmitter signal, okay, in your electronic circuit. When the signal strength become less than the required value, the amplification can be done anywhere in between transmitter and receiver. Okay, so earlier we have seen, so between this transmitter and the receiving antenna, so you have a channel. Okay, so you have a channel. So in between here, so you can have amplifier anywhere also. Okay, so not necessarily must be here. So it can be here. So let's say you are transmitting over very long distance. So here you are transmitting 5 volt. Okay, over time, so because there can be a friction or some energy is converted to it, so 5 volt can become 4.8 volt. So you need to have an amplifier to increase it back to 5 volt. Okay, so that the receiving antenna can get the uh, actual value. Okay, so that's the function of amplifier. So it can be done anywhere in between transmitter and receiver. Okay, so usually the amplifier will be connected to a DC power source. Okay, so modulator. So yesterday we stopped until here. Okay, so what is modulator? So modulator is a bit like important for you to understand, because we will have the second chapter, AM and also FM. Okay, so amplitude modulation and also frequency modulation, so which we will study in the upcoming chapters. Okay, so there can be some calculations involved as well. Okay, so what is modulator? I just read this first. So as the original message signal cannot be transmitted over a large distance because of their low frequency and amplitude, they are superimposed with high frequency and amplitude wave called carrier wave. Okay, so this phenomenon of superimposing of a message signal with the carrier wave is called modulation. So, and the resultant wave is the modulated wave, which is to be transmitted. Okay, so to make you understand, so yesterday I was telling your friend, okay, he asked what is modulation. Okay, so let's say you want to go from Perlis to Kuala Lumpur. So I use the same example. So you want to go from here to Kuala Lumpur. So if you want to go by yourself, how long it will take? Okay, so yourself without any assistance. So let's say you want to walk from Perlis to KL. So yesterday your friend say it can be 11 days. Okay, so I'm not sure. I never tried before. But of course, it cannot be reaching in a very short period. So you need to walk almost like 500 kilometers, okay, just to reach to the destination. Okay, so if you don't have a time constraint, then it's fine. So you can just walk. Okay, 11 days or so it's okay. So you can just walk. So let's say you need to deliver something within 1 hour. Is it possible for you to walk from Perlis to Kuala Lumpur in 1 hour? Cannot. Okay, so you need to have an assistance. Okay, so let's say you want to reach within 1 hour. So the fastest way is to take an aeroplane. Okay, from Alusta Airport you take to Kuala Lumpur, so you can reach in 1 hour. Okay, so from this example we can see, so ourself is the original message. Okay, so we are the original message signal, and we cannot be transmitted over large distance because we have a low frequency, we have a low capability, our walking speed is not fast. Okay, so speed is related to frequency and amplitude. We cannot we have a very limited capability to do that. So what we need to do, so we need to superimpose ourselves with the high frequency and amplitude wave. Okay, so higher speed travel is by aeroplane. So what we need to do, we just need to take a aeroplane. So you need to board into the flight, so to KL, then you take the flight. So once you reach KL, so you detach yourself. Okay, so the process in Alusta where you take an aeroplane is what we call as a superimpose. Okay, so yourself as the original message, you are joining with uh, another carrier wave, so which is the aeroplane. Okay, so once you reach there, so you need to detach yourself, so that we call it as a demodulation. Okay, so when you join and you are superimposing, we call it as a modulation. When you are separating yourself, original message separate with the carrier wave, so we call as a demodulation. Okay, so I already explained modulator and also demodulator. Okay, so by joining with the carrier wave, so you can achieve your objective faster. Okay, so you can see here, so what is modulation? So message signal. So let's say this is your message. Okay, and this is a carrier signal. So carrier signal will be always there. Okay, the communication will always go there. So you just superimpose yourself to form a modulated signal. Okay, you send over a distance. So once you demodulate the signal, you will get back a message signal separately, and the carrier signal can be separated. Okay, so that is what we call as a modulation. So there are various type of modulation. So I only list here three. So actually you got more. So you have a digital modulation now. Okay, so you have other types of modulation as well. So you can do some research on this. But these are the three modulations that we can use. Okay, we can use in our daily life. So already using for some time. Okay, because even radio frequency or broadcasting already available for 30 almost like 50 years, 60 years. So it's already evolving. Okay, so the technology is getting better. Okay, so this is an example of amplitude modulation. So this is the example of frequency modulation, and this is uh, phase modulation. Yes, you can see from the shape itself. So it has, so the message can be the same, just the carrier signal is different. So and this waveform is depending on the carrier signal. Okay, so you can see amplitude. So you are playing around with different amplitudes. So frequency. So the frequency or the wave frequency of the wave is expanding or shrinking. So you can see. So you can attach your message signal together with this carrier signal. and you can have a phase modulation. So it can be under 80 degrees changing of phase, so you can attach your message signal in between as well. Okay, so we will look at it in a clearer view in chapter 2 and chapter 3. Okay, then we continue with transmitters. Okay, what is transmitter? It's an arrangement that processes a message signal into a suitable form for transmission and subsequently reception. Okay, so now normally now we don't have a transmitter and receiver. Usually we won't have, because those time, yes. So we must have a separate transmitter and separate receiver to to send and also receive signal. But now we already have a combination of transmitter and receiver. We call it as a transceiver. Okay, so but here the explanation is given for transmitter. So it's an arrangement that processes the message signal into a suitable form. Okay, so once you receive the modulated signal, so you want to transmit it to the receiving station or receiving antenna. So the transmitter will continue to package it in a suitable way before transmitting it to the receiver. Okay, so for transmitter, it always come together with the antenna. Okay, so this is the antenna we usually will see in the house, Astro. Okay, so if olden kind, we can see different kind of antennas as well. Okay, so antenna is a structure or device that will radiate and receive electromagnetic wave. Okay, so they are used in both transmitters and receivers. An antenna is basically a metallic object, often a collection of wires. The electromagnetic waves are polarized according to the position of the antenna. Okay, so I don't know whether you have experienced this. So those time when we have the normal antenna on the roof, we will try to turn it so that we can get a better TV signal. Okay, so similarly, so even Astro, the technician will do that. Okay, they will try to turn the antenna so that they can get the best signal from the satellite. Okay, so it's actually a structure. So antenna will be combining with transmitter or receiver. Okay, so can be in both transmitters and also receiver. So it's actually a structure that radiate the electromagnetic wave. So because usually when you want to transfer it to a certain certain places, if you are not you want to use a wireless way, so we usually will utilize the electromagnetic wave, and because we have abundance of electromagnetic wave in our normal air, so we will try to use the electromagnetic wave. Okay, so the antenna is a metallic object, collection of wires. So there are a lot of wires inside. Okay, so and the electromagnetic wave are polarized. Okay, so polarized is it means that you are trying to get the best electromagnetic wave in order to transmit the message. Okay, so channel. Okay, so channel or the transmission line. So it can be a wired or wireless. So it can be either way. Okay, so like how I said earlier, so we have a normal air, okay, surrounding us. So there are a lot of electromagnetic waves in between. So we can utilize that. Okay, utilize that to transmit. Okay, that is what we call as a channel or transmission line. Okay, so a channel refers to a physical medium such as wire. So it can be wires, okay, the normal wires that we can see, okay, and it can be cables like a LAN cable that we are using for internet. So it can also be a space through which the signal is passed from the transmitter and the receiver. So as long you have a transmitter and receiver with all the setup, and you have a medium for the transmission to happen and the receiving to happen, so it is possible. Okay, there are many channel impairment. Okay, so we will see this later. Channel impairments means there are some loss of information in between. Okay, that affect channel performance. Because if you want to place an antenna and also the transmitter antenna and also receiving antenna, but in between there's a hill or there's a big building. The transmission might not happen uh, in a good way. So maybe there can be a loss in between. So all these can affect the channel performance. So noise and attenuation and also distortion are to mention as a major impairment in the communication system. The impairment will be explained further in the next subtopic. As I will explain later. Okay, so the receiver. Okay, so what is a receiver? I already explained. So similar like transmitter. Transmitter will collect the message and it will send. So receiver, it will receive. So it's the opposite of transmitter. So the arrangement that extract the message or information from the transmitter signal at the output end of the channel and reproduce it into a suitable form as a original message signal. Okay, so once you transmit, so you already modulated, you already packaging it nicely and you send. So the receiver will receive, then it will open the packaging and it will reproduce in a suitable form as the original message signal. Okay, so provided no loss in between. So if there's a loss, then maybe the original message signal is only maybe 80% correct or 70% correct. So that's why we need to eliminate losses in between. We must try to minimize. Okay. So demodulator I already explained earlier. So it's the inverse phenomenon of modulation. Okay, the process of separation of message signal from the carrier wave take place in the demodulator. The information is retrieved from the modulated wave. Okay, so earlier I say about the example of the aeroplane. So you're superimposing yourself with the aeroplane. So you are taking the aeroplane, you go inside the aeroplane, and you travel together with the aeroplane to Kuala Lumpur. So once you reach Kuala Lumpur, so you need to get down from the aeroplane in order to continue. You cannot bring the aeroplane along with you. So aeroplane will be at the destination place. You need to detach yourself. So the separation of message signal from the carrier wave. So that is what we call as a demodulation. It is happening in the demodulator. Okay, so we also can have repeaters. Okay, what is repeaters? So you can see the picture here. So repeaters are placed in a different location in between the transmitter and receiver. Okay, so let's say you want to transmit from here, you can see an antenna here. So you try to send, but suddenly there's a hill in between. Okay, so the signal cannot go well to the destination or the receiving end. So what you need to do? So you need to put a repeater in between. So that's why we can see in a high-rise building, tall buildings, or on top of the hill, we can see a lot of antennas will be placed there. So that's the function of repeaters. So it will send the message here. So it will repeat back to the location, to the destination. So the hill in between or the high-rise buildings in between will not become an obstacle for you to communicate. Okay, so it will place in a different location in between the transmitter and receiver. The repeater receives the transmitter signal, amplify it, and send it to the next repeater without distorting the original signal. So the function of communication, we want to maintain the originality of the signal. So let's say you are sending a message A B C D. So make sure the receiving end receive it as a ABCD, not ABC or ABCDE. Not no additional or lesser than whatever you send. So that's why the repeater is very important. Okay, so it can be placed on the hill or on top of high-rise buildings, or we even can have the antenna structures. Okay, structures that we can see near our house. Okay, so normally all the telecommunication system, all the antennas will be placed in one pole. Okay, so all that are placed for this purpose. Okay, so even now we are using Wi-Fi in the house. So let's say we have a lot of rooms. So in between of the rooms we have walls. Okay, so walls that separate the rooms. So even sometimes the Wi-Fi signal cannot penetrate, cannot enter the wall. So you cannot. So let's say here we are sending 100 megabyte a bit per second. So you are saying Mbps you are sending. So maybe because of the wall, so the other end will receive only 70 or 50. So you can have a range extender in between. So this is the Wi-Fi router. This is the main one you put at the center of the house. So maybe it only cover this place. Okay, the purple one. So if you want the rooms to get the signal, so you need to put a Wi-Fi extend as the range extender here. So it will cover the room. Okay, maybe here you need to put another range extender. Okay, so that's the function of of a range extender or repeater. Okay, so or now they have a lot of like mesh system, which can send Wi-Fi signal at a different frequencies. So sometimes we can see 5 and 5 Gbps, okay, or 2.4. Okay, so 2.4. So 2.4 it can send further, but at the half of the maximum speed. So 5 gig 5G. So 5G it can send uh, at the maximum speed at a smaller place. Okay, so we can have a lot of technologies that are improving in terms of us getting the maximum. Okay, so the channel impediment. So earlier I have told. So what is impediment? So you are sending a signal from the source. The source will generate the information sent to this channel. So channel. So there can be three types of impediment happen. So impediment means loss of function or ability. Okay, so like you can see here, you are sending. So this is your source, 5 volt. You are sending 5 volt, and there's a resistor in between. So when you have resistor, so there can be some electrical voltage can convert into it, the other form of energy. So let's say here you have 0.1 volt loss, and the receiving end will only get 4.9 volt, so it won't get 5 volt. Okay, so this loss is considered as an impediment. Okay, so suppose we send 5 volt, you must receive 5 volt. So you try to minimize this. Okay, minimize this by either replacing or by amplification or something lah. Okay, something in order to get back 5 volt. Okay, even though there's a loss. Okay, that's a function of us as an engineer. So we need to prevent whatever losses that can happen. Okay, so the signal transmission. So we can see the original message cannot be transmitted over a large distance because of its low frequency and amplitude. So let's say this is your original message. Okay, you send over a long distance, so the signal will be attenuated. Okay, so attenuated meaning the signal strength become weak due to the presence of noise interference along the communication path. Okay, so earlier the example. So let's say you want to walk from Perlis to Kuala Lumpur. So in between you walk, you become tired. So your signal become weak. So you need to take rest. So suddenly there's a lot of traffic. So a lot of obstacle in between. So over time, the signal will become weak. So that is what we call as a attenuation. Okay, so that's the original signal are superimposed with the carrier waves, high frequency and amplitude wave to transmit the signal. Okay, so you can see the example here. So let's say the original message is 2. Okay, let's say it's 2 volt. Okay, the carrier wave is must be higher frequency and also amplitude. So let's say it's 10. So when you superimpose, it will become 2 plus 10. So it will become 12. So it will be traveling until the destination. So once it reach the destination, so 12 minus the carrier wave, which is 10, then you will get back to. Okay, so it's like taking a public transport. Okay, in order to reach a destination. Okay, so what is attenuation? So I already mentioned earlier. So attenuation means the loss of energy. Okay, so this is your original message. After you transmit over a point, so original message is 0.1. So at point 2, you can see the amplitude already became weak. It became small. Okay, so once you reach this, so you need to have an amplifier to amplify it back to the original wave. So once it go through amplifier at point 3, you can see it already became like the original message. Okay, so I think I already explained this. So to compensate with this loss, amplifier are used to amplify the signal. So amplifier, you must know, you cannot over amplify a signal or lesser amplify the signal. Okay, so you must know the original message, how many voltage. So let's say after some time it become from 5 volt, it become 1 volt. So the amplifier must increase it to another 4 more volt so that you can get 5 volt. Okay, so you must know the gain of the amplifier. Okay, that is attenuation. Okay, so what is distortion? You can see distortion means the signal changes its form or shape. So distort means so there's a changes in the shape. Okay, so you can see, so this is the composite signals, and so you can see the signal is having like two curves here. Okay, and down here you have another 2 curves. So once you this is what you send. So you shouldn't after some time after the receiver it become like this. So from this shape it become like this shape, meaning there are distortion. So distortions happen in between. Okay, so distortion can occur in a composite signal made of different frequency. So composite means it's a mixture. Okay, so you can see here components. So let's say this is a 3-phase. So you can have this component and with this amplitude and also frequency. So you have this with a different amplitude and frequency, and this waveform with the different amplitude and frequency. So you combine together to form this. Okay, so that is what we call as a composite signal. Okay, so each signal component has its own propagation speed, okay, through the medium, and therefore its own delay in arriving at the final destination. So let's say this example, so this person is using aeroplane, so this person is using bus, so this person is using going by walking. So everyone will have a different speed, yeah, when reaching the receiver. So and because of that, it can create a difference in phase. Okay, because it's not exactly the same period of duration. So in other words, signal components at the receiver have phases different from what they had at the sender. The shape of the composite signal is therefore not the same. So you can see it's not the same. So if this thing happens, so it means that there are distortions. Okay, so see one more. Okay, noise. Okay, so we always hear about this word, but in communication system, so noise means it can be another cause of impairment. So there can be several types of noise. So it can be a thermal noise, so because of temperature differences. So it can be induced noise, so something that is generated in between. So it can be a crosstalk. So crosstalk meaning, so there can be effect of wires, other wire, because normally when we send, so wire will not be only one. It can have various wires joined together. So it can have a signal interference in between. So you can have an impulse noise. Okay, it can be like a spike, sudden spike because of electrical or sudden thunderstorm or lightning. So you can have sudden impulse noise. So it can corrupt the signal. Okay, corrupt the signal. So thermal noise is the random motion of electrons in a wire which creates an extra signal not originally sent by the transmitter. Okay, so thermal noise is due to electrons and also the temperature differences between, because when electron move from one place to another place, it will generate heat. Okay, so the heat that generated will become like the input to the next wire. So then it can cause some noises. Okay, then we have induced noise come from the source, such as motors or appliances. So now normally you can see, so you are watching TV at your house, suddenly your mother on the grinder, so you can see some kind like a distortion on the TV. So it's because of some induced noise, which comes from the motor or appliances. Because at times, the more electricity will be drawn by the motors, okay, which causes some kind like a shortage. Okay, these devices acts like a sending antenna and the transmission medium acts as a receiving antenna. Okay, so these are related to the induced noise. So crosstalk, I already explained earlier, the effect of one wire on the others. Okay, one wire acts as a standing antenna and the other as a receiving antenna. Okay, so when effect happen between wires, so one will become sending and one more will become antenna, receiving antenna, so it will have some kind like a communication. We call it as a noise. Okay, so impulse noise is a spike. Will have energy in a very short time. Okay, suddenly because of power lines, power shortage, or power surge, or lightning, so it can cause a sudden spike. Okay, so you can see here. So let's say you are sending from point one, so you are transmitting this shape, and during the transmission medium, suddenly at lightning, suddenly there's a spike. Okay, spike because of the lightning. So when you receive, the shape already different. So this transmitted and also receive signal, when it is demodulated, it will become a new shape, which is not accurate. Okay, so we need to remove noise as much as possible. Okay, so that are the three things that we saw: so attenuation, distortion, and also noise. Okay, which can affect your communication. Okay, so we need to, when we are designing a system, so we need to make sure we minimize all this effect. So we want to eliminate totally, maybe it's impossible, because we are co-living together with all these things, but we can minimize it. Okay, so even mathematically, or we can use some kind like devices in order to minimize attenuation, distortion, and also noise. Okay, so with this we are concluding chapter 1. So chapter 1 is only introduction to communication system. So we want to expose you to the terms involved in communication system and also networking. Okay, and we have seen some of the elements or components of communication system. Okay, so we can see a quote from Sidney J. Harris. Okay, the two words information and communication are often used interchangeably, but they signify quite different things. Okay, usually we will say, oh, information mean is a communication. So that's our understanding. Okay, or sometimes information we will think is a communication. Communication we will think is information. But Sydney J. Harris is saying it's actually two different things. Okay, information is giving out. So you're giving out whatever you know, you're giving out. Communication is make sure whatever you give out reach to the destination. So it's a totally working together. So working together in order to achieve a successful communication. Okay, so any question? Okay, so we have already complete chapter one. So any questions so far? No. Okay, so I don't see any questions in the chat box also. So I hope you can get a good understanding of chapter one. So videos are given. So if you want to make sure, because this subject is quite easy to pass, because it's full theory. So it's whether you study or not. Okay. So if you are not studying, then you cannot understand because there are a lot of terms involved. So you need to make sure you know how to explain using the terms. Okay. So if you are uh, not understanding it quite well, so please listen back. So we listen back to the videos are given so that you can understand better. Okay.